Thank you all. So excited to be here today. My team is a huge Antisyphon training fan, and I'm sure I've got a couple folks watching right now. But this talk is really about taking your threat intelligence reports to actionable hypotheses, because the number one thing that I think a lot of us challenged with is the volume is just getting more and more and more and more and more and more. I can't tell you how many threat intelligence reports just die in my inbox on a daily basis because there is so much coming at us at any given time. Um, like everyone mentioned, my name is Lauren Proehl. I'm the global head of detection and response for Marsh, largest insurance broker in the world. And I'm also the co-founder of THOR Collective. You had one of my other co-founders on earlier today, Sydney. And we focus on bringing actionable insights to the community for threat hunting. So it's really, really important that it is us versus the adversary. And we believe in building AI-powered defenses, threat hunting defenses, all of that in the public so you all can benefit. Um, so the problem statement of this is a lot of intelligence dies in a Slack channel, and that is not any fault of our wonderful threat intelligence teams and partners, right? It's more of a volume problem. It's more of a, we have so much going on at any given time that when Google and CrowdStrike and Palo release something on ClickFix and ScatterSpider and anything on the same day, how do you prioritize that? How do you turn that into something, right, actionable that you can then take? And it is all over the place, right? Every day I feel like there's a new report popping up and sometimes multiple from the same vendor. And we really encourage threat hunters to do intel-driven hunting, right? You want to hunt things that are relevant. If you've ever seen any one of my talks before or read any one of my blogs, I always use the example of if you're a bank that only operates in Chicago, Illinois, you probably shouldn't be threat hunting for malware that infects North Korean grocery stores, right? And intel-driven programs really help you prioritize what you should be looking for and having the biggest impact. And that puts a lot of onus on our threat hunters. You need to go through the report. You need to take out the behaviors. You need to make sure that you understand what you're hunting for, put the pieces together. You do the Charlie Day meme and everything's connected with a red string. And so oftentimes you find quite a bit of published reports just ending up sitting in an Intel channel in Slack or sitting in your email inbox or added to your RSS collector. And what this talk does is aims to show you how you can process the volume of intelligence reports at scale so you can turn them into actionable hunt hypotheses. And I'm gonna give you the punchline here up front. If you are able to turn out really, really good hypotheses that follow a common schema, common format from this intelligence, that is the first step in getting AI-powered threat hunting going. Whether or not you do that completely autonomously or human in the loop, right? That is up to you and your organization. But you need to have a set of instructions that you're feeding to these AI agents that they understand, they've seen before, and they can build a memory from. And building hypotheses is the very first step in that. So we all know indicator-based hunting is not enough these days. Most of our adversaries have been built to beat a block list. You've seen that change over the last 5 to 7 years. Adversaries are using Rustdesk, all right, and Microsoft RDP and off-the-shelf things, lolbins, you name it, to avoid getting detected and blocked with volatile and individual indicators. For this talk, I'm going to give you all the prompts you can use to do this in your own environment with your own LLMs. That is totally up to you. It's just a starting point. But I tested this against the April EtherRAT and tuk-tuk intrusion report that was published by the DFIR report. And so doing this process, I were able to extract the exact behaviors and really solidify that indicator-based hunting and indicator-based blocking is not enough, right? So it's very hard to block a Cloudflare tunnel when you're rotating Cloudflare tunnel subdomains every 30 minutes or every 60 minutes. It's very hard to have decoy domains in there and then be able to implement effective firewall blocking. So part of the reason this is so important is you need to be able to process at scale what is an indicator and what is a behavior that you can hunt, which is what we're always trying to focus on. So the core function of this is I wanted to make sure that an intelligence report becomes a structured and testable hypothesis. I didn't want a summary. I didn't want the IOCs, although AI has been really, really good at handling pulling IOCs out of PNG files and PDFs when I can't copy and paste. But I wanted something that if I handed it to a human, they could run this and get behavioral-based results. Because that's the ultimate indicator of success here for me. If I hand something to my smartest humans and it makes sense, it's logical in its flow, it's logical in its structure, and it can be testable, I consider that a good hypothesis. So I broke it out into 4 different parts that made the hypothesis real. A map TTP, so that we know what we're hunting for from a behavior perspective. And this gets into, from a larger programmatic perspective, what are you testing? What are you tracking? How are you following things? I required that the hypothesis have required data sources, because the last thing I needed was a hypothesis that said, oh, I'm going to go hunt for, let's say, new rules being added to exchange mailboxes. And then it gave me a pseudo query that was focused on firewall rules. And so I wanted to make sure that what is being hunted and how it's being hunted were very clearly linked together. I also forced the AI to output analytic logic with essentially pseudocode query language that could get your hunter started. And then I also did a validation step. So what the expected results would have been for a threat hunter running this and the potential false positives that might have appeared with this behavior. What I did with this 4-part piece is essentially built a contract. And so if the model could not fill in all of these details, which after a lot of testing is kind of the bare minimum of what I needed to actually start a threat hunt, then the hunt didn't exist and it had more work to do. And through the testing of the prompting, the plugins, and how we validated all of this, it became really apparent that these were the 4 core components that were non-negotiable for the AI to extract and then extrapolate. So it is the 4 steps every single time for every single intelligence report, for every single article. Number 1, extract the Tradecraft. I prompt, and I'll give you again all of these prompts. We pull all the behaviors and sequences and drop the volatile indicators. So I specifically didn't want IPs, domains, or hashes unless it made sense in the sense of behavior, right? So unless it was people are exfiltrating to shared like box.com or Google Drive accounts, right? Then it makes sense to have those indicators because it's a part of scoping that behavior. But just searching for any hits to drive.com didn't make sense. I then forced the AI to map to attack and map each behavior to a technique ID very specifically. And as a sub-function of that, I forced the AI to verify that the attack technique exists. This is super important because the training data can often be quite stale with some of the models that you're using. And so you can end up having a fair bit of hallucinations with that if it's not validating against the actual live attack matrix. And then force it to scope data sources based on everything extracted from step 1 and step 2, as well as any research that it does into the attack and the contextual threat intelligence that was given to it in the report. And then it generates the analytic logic, again, based on everything it got from step 1 through 3, all of the intelligence, and then also feeding it access to publicly available manuals for respective tools, Splunk, Defender, you name it. And then lastly, at the very end of the prompt, I force it to validate and confirm the logic holds against real data, and then feed what works back into the next report. And I essentially force at the end of a prompt a Lauren filter that's like, would my boss be angry at me producing this? Yes or no, here's the qualifications, and give this a grade on an A through an F scale. So in step one, and this is the prompt that does it. I will have, again, on a GitHub page, the prompt pack that you can actually copy out. On step one, it is very, very specific with instructions. Keep process lineage, command line patterns, persistent C2, lateral movement, CRUD access, variant C2, all of this stuff. I define exactly what to keep and then also what to drop, because throughout the testing of this prompt, the difficulty of the AI is that if you are not explicit, it will often miss things and or hallucinate things. And so you have to put those guardrails in place so that you can define what you need. I essentially defined everything from the kill chain, the high level tactics from MITRE ATT&CK, all of this as things to keep, right? And then saying ignore hashes, IPs, single use domains. I also force it to tag with the kill chain phase and the actual command and path when producing the hypothesis, because this gives a more holistic package for the hunters. Step two, and this is where we talked about some of the issues with hallucination, is map to attack and check the model's work with mapping to attack. So a lot of these models have training cutoff dates that are before the most recent version of MITRE ATT&CK's release. And so what you end up happening is it will assign techniques that either don't exist anymore, got merged, or maybe don't even exist at all. And it makes a lot of assumptions. So as a part of this prompt, I built in the MCP to MITRE ATT&CK so that it could go directly and call and validate as it's doing this. And if it doesn't know or cannot verify against the live matrix for whatever reason, right? There's a network blip, it freaks out at the context window, anything like that, the prompt forces the model to put a verify flag on there so that the human then can go review. And again, lessons learned of everything that I found that it does wrong. It invents technique IDs that look right and they don't exist. It oftentimes picks the parent technique when a sub-technique is actually more appropriate. It'll map the tool, not the behavior. This was like a big portion of it. It'll actually end up mapping like a GoToMeeting or rest desk or something like that. And it'll match where that is referenced in the rest of ATT&CK instead of actually mapping the behavior for that. So I try to enforce the rule of always diff against the live matrix. As you all know, with AI, sometimes it listens, sometimes it doesn't, but there's the flag to catch if it doesn't listen, which helps. Then the other thing that I realized throughout developing this process is it doesn't help if I can't run the hunt or if I don't know where to start. And so I forced it to, in this version of the prompt, do a KQL first pseudocode query language, essentially. And I got super specific because when I first started this, I was like, hey, develop query language for this. And it made up indexes. It made up event IDs. It made up events that just didn't exist. And so it'd be like from EDR telemetry, pull login events, and then group by host name or something like that. I'm like, well, that's not realistic. And so after I pointed it to the publicly facing documentation, I found that I got much better results that were usable. The other thing that's really important for this is I want this defined because if you go to run this and the telemetry doesn't exist, that is a finding from your hunt or your attempted hunt. And so it's really, really important that we are defining specifically what telemetry we want, what event IDs we need, because that's important in terms of tracking and getting better. So you can see things like device process events being pulled from the EDR. It defines very specifically like event 4769 or 5136 from Windows. It also can get some nice 7045 for device process events around egress proxies. What I will note is Hearth does a lot of this for you already. So as part of THOR Collective, this is something that we do You can submit to the Hearth repo any threat intelligence report. It'll extract everything for you, and then you can feed it back in the community to make everyone around us better. So if you want to set this up in your own environment, but you want some examples of how it works, you can absolutely do this on the Hearth repo just to get a feel and see what the outputs look like, and understand how this may work at a grander scale. And then lastly, what this ends up turning into is the hunt card, which has these 6 different fields and values to have one repeatable shape for every hypothesis. And again, this is what is required to scale your hunt program from, hey, I'm a solo threat hunter running this one time, to a scalable hunt program that can be more agentic. I always make the hypothesis one sentence, which is the behavior we expect to find. We have the attack IDs, we have the data sources. We want to make sure that we've got named tables and event IDs, analytic logic, validation, and then we also do the peak category, which is hypothesis baseline or model assisted. Again, all of this information is really, really important to help you frame and scope the hunt that you're about to do so that you are not walking around blind on an island looking for treasure without a map. So when we look at prompt crafting, what actually can take a Sophos report and turn it into something that we can actually use for a hunt? Step 1 is framing the role. We need to do this because it helps give context to why we're asking for this. So there's always a system prompt at the very beginning of all of my prompts. It's not just extract all the TTPs and tell me what they map to in attack, because we're not framing that ask, right? We want to say, hey, you are a senior threat hunter. A lot of the AIs were trained this way. They're very, very comfortable with this language and this framing. From there, we go to cover it all. Cover every behavior invariant, not just the flashy ones. And we have to define this rule because AI is going to break it if we don't give it the guardrails to play in. Defining real field only, defining validate always, and then banning indicators, because I really don't want IOCs in a trench coat dressed up as a behavior. And this is, I've been through iterating this enough times that I know that if I don't say explicitly not to do this, AI is going to try to do this because it thinks it's being helpful. And so you can see the system prompt that I will include in the prompt pack for you all, which is that initial framing. It's setting up to do the actual thing. So you put the model in the right thought track, in the right process path, instead of just asking for it to extract behaviors in TTPs raw without the context. So we talked about what inspired this, the DFI report from May 2026. This is the EtherRAT to tuk to the gentleman ransomware. I took this link directly from DFI report. I ran it cold with a net new model that I didn't develop this process on, with the full prompt, and the run produced 14 hypotheses plus hunt cards across the chain. I'm going to walk through 3 of those examples so you can kind of see, and we can talk about some of the nuance here. There are, I think, 4 other examples on my GitHub, or excuse me, 4 total. There's a ClickFix example, a cloud logging example, a Mac Sapphire Steel example, and then this EtherRAT example, all run with the same prompt pack that's available in the GitHub. So you can see how AI handles different scopes, different scales, different complexities of threat intelligence reports, all of that. And it followed the process exactly. Found a bunch of gaps, found things that I ended up needing to human in the loop to fix, and did a decent job at producing these hypotheses that I could then turn around and either hunt myself or proceed to ask an agent to hunt. So Web3C2 resolution. This is the exact output from this. It analyzed and said this was one of the sharpest hunts that it found. Sometimes the hypotheses, they get a little sassy with that. So endpoints with no business touching Web3 or resolving C2 through blockchain and decentralized storage. That is a wild hypothesis. What is really interesting is why it matters, the data source that it recommended to me, and then the analytic logic that it ended up giving me. And so it pulled out the IOCs that were specifically named as associated with this in the EtherRAT report. But what you see is it's not just searching for 1rpc.io, rweave, anything like that. It is also saying the process is initiated from Chrome, MS Edge, or Firefox, right? And it's not in a baseline. And then it clearly articulates the validation of sometimes there are development and blockchain teams that do this, right? So you should baseline the expected Web3 usage first and alert on the rest. Again, a really, really good initial starting point for me as I'm thinking about how do I approach this and how do I start this. The second is Trojanized signed binaries. Again, we get a little sassy in our hypotheses, and you can fix all of that by modifying the system prompt that you're giving. You can say, more professional language and whatnot. There is a blog that I have about how you actually write hypotheses and do hypothesis mapping to make sure you have all the elements that you want. So you can feed it that blog and that method and say, this is how I want you to write your hypotheses. There's a lot of tweaking you can do here. But this talks about legitimate signed apps running from odd paths, making outbound connections. And again, you can see them using the specific loaders that were referenced in the report, where this file name is in loaders, join, and a distinct, right? It's not perfect. This is a first shot, but it's a good starting point, and you can develop this based on what actual logs you have available, if you see different loaders, all of that. Interestingly, it also comes back to the validation of pinning known good install paths, and then anything that deviates from that is something that you should evaluate, which is always a good methodology. RMM, or remote management tooling, as a C2 channel. This is one that we're always going to have fun with. This is, again, one of the lower level ones. We're looking for AnyDes, we're looking for Screen Connect, not just looking for process command, but also where there are remote URLs happening there. The AI really likes to lean on, you should already know what's happening in your environment, and so there should be an allow list or a baseline reference. For a lot of us, we know that is not true. When you're looking at, building this, one thing that kind of takes this process to the next level is having some sort of RAG mechanism or DCI database that has context about your organization that the AI can then reference to help transform these. So this was run no additional information besides the system prompt and the prompt pack that I gave it. If I'm looking at this from an enterprise or an organizational perspective, I want to make sure that there's additional context available to the AI to say, we run GoToMeeting as our approved software. And so it'll be like, well, that's probably not valid for you to hunt, or you need to baseline that and then use that as a part of the analytic logic. So like I mentioned, we've already built this for you. If you go to hearth.thorcollective.com/submit.html, you can actually auto-submit a CTI link. It'll open up a pre-filled GitHub issue for Hearth, which is it's essentially our threat hunting repo. There's a little over 200 hypotheses that have been submitted by the community that you can run in your organization today. So if you're ever like, I don't know what to hunt for, you can go look at Hearth and see some things that other folks have already hunted for and had great success in their organization. But if you want to see how this works, you can go to this link. AI will draft your hunt. We'll actually do a dedupe check against any existing hunts, and then we'll PR it to the open library, and Sydney and I will review it and then integrate it into the repository. It won't die. You can see how this process works in a more productionized pipeline. And as a bonus, you are giving back to the threat hunting community. So if you want to say like, hey, there was a new Microsoft report that just came out, you can submit that here. It'll extract all of that, give that, and now the community has access to those hunts from that threat intelligence report. So you get to take this with you. I'm giving you a prompt pack, and I'm giving you two things in the prompt pack. One is the one shot, which has the system prompt and all of the steps that you can run at one time. So you can just say, boom, DFI report, one-shot prompt, go look at this, give me an output in a markdown file. The second I gave you is step by step. So you can run the stages in turn. So you can read, steer, make edits in time if you want this to be a little more human in the loop. Both end in the same way. You're still going to get the same output. You just have a little bit more control with the step by step. You do need to do some verification, though. As I mentioned, AI can hallucinate, and we've seen that with quite a few examples in the early runs. So how do you fit this together? When do you need to reason it by hand, and when do you let the pipeline draft? What I will say is I highly recommend having automation and AI augment your threat hunting program. Let the automation and AI draft. You should have your humans determine what is real. Become that senior level, become that reviewer. The breadth and depth that we are experiencing as a community right now is ridiculous. The volumes are so incredibly high. You want something that's routine, repeatable for everything that is coming in. We've already talked about where AI fails. Validation is 100% the job. Just be aware, AI always hallucinates. I highly recommend reviewing everything that you have. If you're a solo hunter, this will help you go from a report to a runnable hunt in minutes. And for a mature program, this can help you dedupe your backlog, make things a little bit more repeatable, and increase your coverage across the team. That is the end. Thank you, everyone, for joining. The edge is the human who decides what's real. I highly recommend letting AI help augment your program. Hearth at THOR Collective.com has over 200 hunt hypotheses you can use today. And then my GitHub is linked at the bottom, report to hunt, where you can get the prompt packed and see all the examples.